Hello and welcome to my channel. My name is Fyodor Sazanovets and I'm a senior software engineer specializing in .NET. On my channel I talk about various stuff related to software engineering and software development. In today's video I will show you how easy it is to set up a SignalR hub in .NET application. For those of you who don't know what SignalR is, it is a library available in ASP.NET Core that allows you to facilitate two-way communication between the client and the server. So, for example, in a normal web application, you would use HTTP protocol or gRPC, which uses request response model. Essentially, your client sends a request to the server, and then server sends data back to the client in the response. With SignalR, what you can do is facilitate two-way communication. So basically, there is a persistent connection between the client and the server, and messages can travel both ways while the connection is still active. SignalR does it by using the WebSockets protocol, but it can also use other protocols if WebSockets is not available. For example, it can use server-sent events or long polling. SignalR can be used in many different application types. For example, if you order some food and you're tracking the delivery, you can have a look at the delivery location on the map. Likewise, when you use chat application, you don't want to refresh the page to see if there are any new messages. You want to see them right away when people write those messages to you. Let's now have a look at how easy it is to set up a SignalR application. SignalR is inbuilt in ASP.NET Core, and it doesn't require any additional NuGet packages. So we have this application here called Basic SignalR App, which is an MVC application. If we open the project file, we can see that we don't have any NuGet references here. We don't reference any third-party libraries. Then we'll open our program.cs file. To add SignalR dependencies, we just call add_SignalR method on the services in the builder. And then we have to register our SignalR hub. In the SignalR terminology, hub is a class that facilitates communication between the client and the server. We have this class called Learning Hub because we are using that to learn SignalR. And we are mapping it to the Learning Hub URL path, which we will see in a moment how it's used by the client. The hub is located inside of our hubs folder. And this is what it looks like. A SignalR hub needs to Any SignalR hub needs to inherit from the hub class of Microsoft.ASP.NET Core.SignalR namespace. And here are the methods that it has. Broadcast message is a method that our clients can invoke. It has one parameter of a type string called message. When it receives the message invoked by the client, it will then resend that message to all the clients that are connected to the hub. We will see how this works in a minute. So, for example, in the context of a chat application, one user may write something to us, and all other participants of the chat will receive that message. In this case, we are using all property of the client's object, which means that we are sending message to all clients. But we can also fine-tune it. We can send message to specific groups of clients, we can send message to individual clients, or the other clients. Let's now have a look at how to set up our client. We are using JavaScript client, even though SignalR client can represent any application. The first thing that we do is adding the client reference. So we will open our layout, and here we have the following line. We are referencing version 8 of SignalR JS library. We are using the version 8 because we are on .NET 8. Every time there is a new .NET release, there is a new version of SignalR server and SignalR client. In our example, we decided to use CDN, and we are pulling this library from a well-known location on the internet. However, we can also compile our own library from the source, like we did with jQuery and Bootstrap in this example here. It's a bit more cumbersome. There are use cases for either using CDN location or compiling our own library. In our case, we've chosen to do this because it's just easier to set up. If we now open our JS folder, this is the JavaScript that we use to connect our SignalR client to our server. Here, we are identifying our connection object. To do so, we are invoking Hub Connection Builder method on the SignalR object. This SignalR object is pulled from the JS library that we referenced earlier. We are setting the path to our SignalR hub that we registered previously in our program.cs class. Because we are using the same application, the base URL will be the same. However, if our SignalR application is represented by a separate application, for example, if we are using it inside of a mobile app, then we will have to specify the whole URL. Here is an optional configure login statement. We don't need that, but we are having that just in case. And we are building our connection from the builder. Once we've done this, our connection object is established, but our connection is not established yet. We are not yet connected to our server. Now we are associating named events with our connection. We are doing so by invoking the on function on it. So here we are associating receive message event with this function. Essentially, when we receive a message, the function expects one parameter called message. We are populating that message inside of a panel with SignalR message panel ID in HTML. We are preparing a div element, and we are populating this div element with the text we received from the SignalR server. If we go back to our hub, we can see here an event called receive message. This is how we map event from our SignalR hub to our SignalR server. Then we have a button called button broadcast. If we click that button, then what happens is that we read the message from an element with the ID of broadcast, and we invoke a method on the SignalR hub called broadcast message with a single parameter called message. This is essentially this method here. It's called broadcast message, and it has a single string parameter. Once we've got that all set up, we start our connection by invoking the start method on it. We can have a look at our index page. Here's where everything is. We have a panel where we can type a message. We have a button that we click to broadcast that message. And we have a panel full of SignalR messages that we receive from the server. Let's launch this project to see how it works. So if I click debug, it will then build the project and launch it in the browser. Now we can see this browser window here. So this is how it works. If I type the message, I click broadcast, it goes to the hub, and then hub broadcasts the message to all connected clients. So if I connect another client by opening another tab in the browser, it doesn't have any messages yet. So if I type message 2, for example, message 3, message 4, and so on, I can see all of them appearing here as well. It's a separate client, but it's one of the connected clients to the SignalR hub. Essentially, what that means is that if any client invokes the hub method, all the clients will receive that message. The message will be broadcast to all the connected clients. The parameters in our SignalR hub methods and on our named events on our client can be of any type that is serializable into JSON. It could be a primitive value type like a string or int, but it can also be a POCO class, any class that can be made into JSON. We can also use multiple different parameters. We don't necessarily have to use one parameter, and we don't have to use any parameters at all. Both named events on the client and the hub methods on the server can be invoked without any parameters, if we don't need any parameters. For example, we may just want to trigger some piece of logic without sending any data to it. So as you can see, SignalR Hub is very easy to set up. By using SignalR, it's extremely easy to build your own fully interactive web application, like a chat application, a delivery tracking application, and so on. Behind the scene, in this example, it uses WebSockets. Of course, there's nothing that stops you from using WebSocket directly. But now I'll show you an example of why it might not be such a good idea. So this code represents how WebSocket is normally implemented. WebSocket does not deal with anything human readable. You have to deal with raw bytes, as you can see here. You have a buffer of bytes, and you populate that buffer with bytes. This is how you send the messages via WebSockets, and this is how you listen to the WebSockets messages as well. As you can see, this code is not very readable. I have to go into a lot of details to explain what it even does. But SignalR does all of this for you. It abstracts away all the implementational complexity. Plus, it doesn't necessarily have to use WebSockets. If for some reason WebSockets is not available, for example, if there's some network restriction that prevents you from using WebSockets, you can still use server-sent events. If for any reason you cannot use server-sent events, you can fall back to long polling. Anything that supports HTTP also supports long polling. But the beauty of it all is that while your communication mechanism might not be as efficient as WebSockets, you will not have to change any of your code, either on the client or the server. All of this will be identical. Your server code will look as if you are invoking specific methods on the client, and your client code will look as if you are invoking specific methods directly on the server. Very intuitive, very easy to learn, very easy to use. So I hope this short introductory lesson was useful, and I'll see you next time.